This lecture begins our unit on waves. First of all, let's discuss what a wave is conceptually. I'll be discussing three of the main characteristics that all waves share. First of all, a wave is an oscillation, which is a type of variation that occurs between a low value and a high value with some sort of equilibrium in the middle. Let's take an example from mechanics. Let's say you have a wall here and a spring with a block attached to it. The block has some mass m. And then let's say you compress the spring so that it's right here. You've moved it away from the equilibrium. This requires force. So when you release the block, the energy stored in the spring will cause the block to move this way to the high end, the amplitude, and return back. This motion will continue, and this traveling back and forth of the block is called oscillation. Secondly, a wave travels through space, or just a vacuum, or through some sort of matter. And the final characteristic is that a wave transfers energy through the space or the matter. Now let's talk about what a wave is mathematically. On the last slide we said that a wave oscillates, which means that it moves between some high value and some low value throughout time. So let's call this our time axis, t, and we'll name this arbitrarily our low value, and we'll call this our high value. Notice that the low value and the high value are the same distance from the equilibrium point. This is important. Here the equilibrium is this zero line here. Since we know that the wave oscillates, we know that it will be changing between the high and the low value. This occurs smoothly in a curve that looks like this. This is called a sine curve. If you've taken trigonometry, you're probably familiar with it. Now we'll identify some of the graphical anatomy of a sine curve. So this distance here, the distance between the equilibrium and the high point, which is the same as the distance between the equilibrium and the low point, is called the amplitude, or A. It's also notable that this function is periodic, which means it'll continue throughout time in the same fashion. So you'd see it go like this, and eventually it would come back down, and you would see oscillation. The length of one repeat is called the wavelength. That's the distance from here to here, because we've seen the wave hit both the high point and the low point. The amount of time it takes for one wavelength is called the period. The frequency, which is measured in hertz, hertz is 1/seconds, is the number of periods per second, or the number of oscillations within a second. In the next few lectures, I'll talk about a few specific types of waves.